So in this video I'm going to sketch the modulus of 2 times the sine of 3x minus 3 from negative pi to pi. So this is in radians, so that's been negative 180 degrees to positive 180 degrees. And on my finished sketch, which I'm going to do on here, I'm going to show the turning point coordinates and the intercepts with the y and x axes. So I've got my sketch final graph ready here from negative pi to pi. But what I'm going to do is, to get to this one here, I'm going to do a series of graph transformations starting from sine of x. So doing it in rough on here first. So I've got sine of x. So what I'm going to do, I'm going to concentrate mostly on the positive side, because sine is an odd function, which means I can rotate it around 180 degrees about the origin and get the corresponding parts on this side. So first of all, let's look at 2 times sine of 3x minus 3. So sine of x, I'm going to transfer then to sine of 3x. So thinking ahead, what happens is when I go from sine of x to sine of 3x, I squeeze the sine of x by a factor of 3. So any points along here will become 3 times closer to the origin. So with that in mind, thinking ahead, I'm going to do my first sketch from 0 to 3 pi. So if I mark pi on here, and then 3 pi, and then sine of x will have a maximum here, minimum here, and a maximum here. So if I go like this, something like that. So this is my rough sketch. I'll try and do a neater one on here. Let's see how it goes. It's not easy. So here we go. So I've got my maximum here, minimum here, and another maximum here. Obviously these are local minimums and maximums. So this one here will be at pi over 2. This one here will be at 5 pi over 2. And this one here will be at 3 pi over 2. Now the maximum points on the y-axis for my sine will be 1 and minus 1. So this is sine of x. And of course, like I said, to get these points here, I'm going to rotate it 180 degrees about the origin, so it will carry on down something like this. Okay, so now what I want to do, I want to do sine of x to sine of 3x. So to transfer this to sine of 3x, so if I now change this to sine of 3x, all I need to do now, because I've thought ahead ready with my points here, because I only want minus pi to pi, this is now going to squeeze by a factor of 3. I can just divide all of these x values by 3. So pi over 2 divided by 3 becomes pi over 6. Pi is just pi over 3. 3 pi over 2 becomes pi over 2. 2 pi becomes 2 pi over 3. 5 pi over 2 becomes 5 pi over 6. And 3 pi, that just becomes pi. So now I've got my ranges from negative pi to pi. So that's all good. Now I need to do 2 times sine of 3x. That'll be my next transformation. So let's start with another graph. Again, just concentrating on the positive ones. So I've got my pi over 3, 2 pi over 3, and I've got my pi. So what I'm going to do now, to get 2 times sine of x, that's obviously multiplying my result of sine of 3x by 2. So that's all I'm going to do now is just stretch along the y-axis by a factor of 2. So where 1 is, it's now going to become plus 2 and minus 2. So that would take care of that. So if I go here, actually I'll just change it on here. Got minus 2 and plus 2. Okay, so now what I'm going to do with that, that's the easiest one to do in terms of my sketch. I now need to subtract 3. So now what I'm going to do is just subtract 3 from all of these. So I'm going to do that on this one, because the last bit I need to think about is my modulus. So subtracting from 3 here, I'm going to end up with minus 1. And subtracting 3 from here, I'm going to end up with minus 5. So if I go down there, try to keep some sort of reasonable scale, minus 1 to minus 5. So here I've got pi over 6. Then I've got pi over 3. Now that point there is now going to be at minus 3. So all of these points here will be at minus 3. So at minus 3, I've got pi over 3. And then at pi over 2, I'm going to have minus 5. So pi over 2 is going to be somewhere here. And then I've got 2 pi over 3, which is going to meet about here. So that'd be at 3. So that's 2 pi over 3. 5 pi over 6. So 5 pi over 6, that's going to be meeting at minus 1. So 5 pi over 6 will be somewhere here. So obviously level with the minus 1. And then pi here from 0 will come down to minus 3. So that will go there. So now what I want to do, this 0 will be at minus 3. So that's my starting point for my sketch. So now what I want to try and do is do a nice smooth as possible curve matching up all of those points. So wish me luck. So there we go. Along there and that one there. Okay, it's not too bad, could be better. But anyway, this is just my rough sketch anyway to show my working. So I'm going to do my line across the middle here for minus 3 so I can see what's going on. Okay, so let's bring that back a little bit neater. So that one there will end up at pi. So it's going to end up there. Okay, right, that's reasonable. So this is now 2 times sine of 3x minus 3. So now what I've got to do is transfer it into the modulus of 2 times sine of 3x minus 3. Here I've got 2 sine of 3x minus 3 without a modulus. Now we know everything inside a modulus is always positive. But here all my values for 2 sine of 3x minus 3 are all negative. So to transfer these into positive, for example, this point here is minus 1. Ignoring what the function is, that's my output. So all I've got now in the modulus sign is minus 1. So this just becomes plus 1. If I take this point here, the output of 2 times sine of minus 3x at this point, which is pi over 2, gives me minus 5. So then there, I've got the modulus of minus 5, which is just positive 5, and that's positive 1. So you can see what happens now. All of these points are now reflected in the x-axis. So 1 goes to plus 1. Minus 5 goes to negative 5, and so on. So let's pick these out. The ones, first of all, on this line of minus 3, they all turn out to plus 3. So this one here, minus 3 is pi over 3. That now becomes plus 3. So now plus 3, pi over 3. Then here I've got plus 3, 2 pi over 3. So that will go there. And here I've got pi, and that's at plus 3. So that's going to be all the bits where it changes either up or down from the original axes on the x-axis. Now the first point as well will also be here, so that takes care of that. This one here is 1, and it will be pi over 6. So I've got 1 pi over 6. Here I've got pi over 2 for my x-axis, but my coordinate now will be 5. So that's going to be right up to where I've written the formula. And then 5 pi over 6, that'd be this one here, which corresponds to this one, which is at minus 1. So now 5 pi over 6 will be at 1. So now all I've got to do is try and sketch curve all the way along these points, and that'd be my final answer for 2 times sine of 3x minus 3. So let's see if we can do that. So we come down here, touch my minimum point there, crossing through there, turning there, back down again, another turning point, and then back up to the point of pi. So now I want to show the turning point coordinates first of all. So there's a turning point, there's a turning point, there's a turning point. So this one here is 1 comma pi over 6. This one here is 5 pi over 2. So let's write that inside the graph. 5 pi over 2. And then this one is 1 5 pi over 6. So that's all of my turning points on the positive side. I'll come to the negative side in a moment. And now the intercepts with the x and y axis. Well, here I've got no intercepts at all with the x-axis, but I've got one with the y-axis, which is here. And that one is simply 0, 3. Okay, now I want to know what happens on the negative side. So now what I want to do is finish off on this side. Now I can see what happens. My graph, it's going to follow this pattern. So it's going to come down, like this, and so on. So all I've got to do now is when these transfer over, this minus 5 here will come to plus 5. So this one will end up here. So my graph will kind of make that pattern now. So now all I need to do is when I go from this 3 here, I just keep going up. So if I keep going up, by virtue of this line here, you see this line here is a nice straight line. When I reflect that, that's going to continue up. So this one is going to end up at 5, and it'll be a pi over 6. This one will be 3, and it'll be minus pi over 3. So 3 minus pi over 3. Here, this one here, pi over 2. Now that one came from over here, so that's going to be at 1. So that's going to be at 1 minus pi over 2. So 1 minus pi over 2. So we can see where our graph is going now. It's going to go down here. Then we need to keep going. This one here is still going to be at 3 and minus 2 pi over 3. And this one here, which was at 5 pi over 6, that's going to be at 5 minus 5 pi over 6. So that goes there. So we can see got our continuous curve. And the last one, which will be at minus pi, which will be at 3. Because that was an x-axis kind of corresponding one. Okay, so now let's finish off our sketch. So that's now going to go through there, down here, continue leaning down here, and down there. Okay, so now let's mark these coordinates. So this one is going to be 5 minus pi over 6. Let's write it there. This one here is 1 minus pi over 2. And then this one here is going to be at 5 minus 5 pi over 6. So we can see now the graph makes this continuous curve along our sketch here. And that's marked all of my intercepts and all my turning points of my coordinates. And that would take care of that. Okay.